Hello and welcome to my channel. My name is Amin Nahian, and today we will be talking about Lewis structures. So it's one of the basic things that you will ever learn in chemistry. It's also one of the most complicated things because initially we don't really know how to do it, especially because something confuses us a lot, the bond lines, right? Some have single bonds, some has double bonds, some have like triple bonds, and we get really confused on which has what. And overall, when molecules become harder as you go, into different levels of chemistry, it becomes really tough. But there is one equation which, if you understand well, you can pretty much crack almost all Lewis structures. And that equation is number of bonds equals to demand minus supply over 2. Hey, what does this mean? It's pretty simple. Number of bonds basically refer to, is it a single bond? Is it a double bond? Or is it a triple bond? Okay. The next part is demand, right? Demand basically indicates how many electrons does this specific atom want. For instance, carbon wants to have 8 valence electrons. And honestly, so do majority of the periodic table, right? There is an exception. So for instance, I believe hydrogen has a demand for 2 because it's a duet, right? Except for that, pretty much everyone wants to have 8 in its electron shell. One of the first things we learn in chemistry. Then what about supply? Supply is a little bit more complicated. Supply basically indicates how many electrons are already available in that problem. So for example, how many valence electrons are originally there? Not the theoretical, not this one, okay? Not this one, nope. We're gonna focus on this one. How many already are available plus the number of hydrogen, okay, plus we will worry about the cation or anion signs. All of this will make sense once we do some examples. If I gave you N2 and I told you to draw the Lewis structure, you'd probably do the trial and error method, which we're initially taught in middle school and high school. But as you go towards next levels of chemistry, it becomes really redundant to do this method because it will take a lot of time. The first step to do any sort of Lewis structure is to count up the valence electrons already available. From the periodic table, we know that N has 5 valence electrons. So overall, N2 has 5 times 2, 10 valence electrons. And then we will draw the skeleton and try to do the old method, single bond, double bond, triple bond, and see. And we will play around, like put two electrons here, there, all this. This is big nonsense. Just follow the equation, and whatever electrons are left, plug it in. It becomes very simple. Number is equals to the demand minus the supply over 2. Demand here, nitrogen wants to have 8 valence electrons. How many nitrogens are here? 2. 8 I want, and I have 2 of them. 2 of them wants 8, so there's 16, right? Minus the supply. The valence electrons plus the hydrogen available and the cation anion, right? How many valence electrons are here? This number right here, 10, right? Are there any hydrogens? No. Are there any cation anion signs? No. So now just divide by 2. We'll get 16 minus 10 over 2 is equals to 6 over 2 is equals to 3. All you now got to do is write N, triple bond, N, because the number is 3. That's the bond, number of bond. Okay? Am I done? If the multiple choice asks for how many bonds will be there between N and N, yeah, maybe. But if I told you to draw the Lewis structure, no, you're not done. Because so far, if you already didn't know, this line basically means 2 electrons. So I have 1, 2, 3 lines, 6 electrons. But I need 10. So that means the rest of them will basically be lone pairs. So now I have 1, 2, 3, 4 electrons, and 6 from here. 6 plus 4 is 10. This is the answer. Let's do a more spicy one. This is the spicy question that will basically test the entire equation. Okay, first step, valence electrons. How many of them are here? C has 4. We all know that. Hydrogen has 1. Sulfur is in the same column as oxygen, so it has 6. And now we're going to do the multiplication because obviously the numbers I mentioned to you is for 1 atom. Well, carbon has 1 atom, so it's going to be 4. Hydrogen has 3, so it's going to be plus 3. And let's see. Sulfur has 6, and it's 1. But I see a minus here because of the anion. So it has gained an electron, so it's going to be a plus 1. So in total, I have 14 valence electrons here. Right? I need that electrons all over my skeleton. So let's establish the skeleton first. Put the carbon in the center because it's a center of attention, as majority of chemistry teachers will teach you. I have H all around it. And for perhaps now, say there is a single bond between carbon and sulfur, right? I don't know whether this right here is correct or not. I gotta check it out. But also remember that S minus, so there's gonna be a minus sign here. Okay, let's check it out. Use the equation, plug in the equation. Number of bond, right, is equals to the demand minus the supply over 2. The demand is carbon and sulfur we were talking about. Demand is carbon and sulfur both want to have 8, right? Carbon wants 8, sulfur wants 8. What about the supply? Carbon, which has 4 valence electrons, so write that number down, and sulfur has 6. Do I have hydrogens? Yes. Hydrogens are there. There's 3 hydrogen. What about any anion cation sign? Yes. Here is an anion, so there's going to be a plus 1. Divide that by 2. 16 minus 10 plus 3 plus 1 over 2 equals to 16 minus 14 over 2. 2 over 2 is equals to 1. That means there's going to be a single bond. Okay, am I done? No. Lewis structure is still incomplete because I need 14 electrons. I have 1, 2, 3, 4. I still need around 6 more. And that most likely will go around sulfur because carbon already has its octet filled. Now, do I have 14? Yes. 6 here, 8 here, 14. Correct. I want you to try this question out on your own. Pause this video and try it. Well, I hope you try to do it on your own. Let's do it together. NO plus. So N has 5 and O has 6, but it has a plus sign, so there's going to be a minus. So in total, there is 10 electrons already here. Okay? What's the next step? The next step is to kind of draw the skeleton. I will draw N and I'll draw O. What is the next step? I have to check out what's the number of bonds between them. Number of bonds equals to the demand minus the supply over 2. Equals to the demand is that N and O both wants 8. So 8 plus 8. And what about the supply? Supply-wise, I have N with 5 valence electrons and O has 6 valence electrons. And then I need to look out for hydrogen, not here, so I don't have to worry about it. What about cation anion? Yes, there's a plus sign, so I put a minus 1 here because it has lost an electron. Divide by 2. 16 minus 6 plus 5 is 11 minus 1 over 2. 16 minus 10 over 2 is equal to 6 over 2 is equal to 3. So that means in total, NO will have triple bonds, right? That means over here we have 6 electrons. But am I done yet? No, I still need 4 more. So all I gotta do is put the lone pairs. And remember that the plus sign goes here, and that is more has to do with formal charge, which is gonna be a different video. I hope you like this video. Please subscribe to my channel and comment down any questions or any other feedback. And please share this video with people because it's the beginning of the semester. A lot of people are struggling. If you know this equation and you pretty much know how to plug in the rest, Lewis structures become really easy. I hope that you'll make someone else's life very easy. Stay safe and continue learning. Thank you very much.